Okay, this is going to be video for lesson 8.7 from the AP Calculus curriculum, volumes, cross-section, squares, rectangles, part 3. In this lesson, we're going to do a few example problems with square cross-sections with simple functions. And so let's go and look at an example. In these problems, you're going to be asked to you're going to be given cross sections sometimes that are perpendicular to the x-axis and sometimes that are perpendicular to the y-axis. If the problem states it's perpendicular to the x-axis, cross sections are perpendicular to the x-axis, you will draw them and integrate with respect to x. If they're perpendicular to the y-axis, you'll draw them with respect to draw them and integrate with respect to y. So let's look at the curve g of x equals x squared. And let's look at a solid. So we have solid square cross sections. Bounded by perpendicular to, we'll start with the x-axis. Bounded by the curve g of x, the x-axis. And the line x equals 4. So we're going to find the volume of that. So we're going to take g of x, which we know is, draw. So I'm getting used to this one note thing. It's going to be the parabola, y equals x squared. We're looking for that region, the square cross sections perpendicular to the x-axis. So we're going to go from intersects the x-axis at 0 and at x equals 4. If we take one of those rectangles perpendicular to the x-axis, whose width is d of x and whose height is x squared, and I pull that out and say, oh, we're going to have a square cross section. And that means not drawn to scale, by the way. Because it's square, means the width of each cross section is dx. The height is going to be the same as the base, or length. And so the volume of that one cross section is going to be x squared times dx. And if I'm going to integrate those from 0 to 4, I will get all of those cross sections generated in this region. So I'm going to integrate this expression for 1 from 0 to 4. And this is going to be x to the 4th dx. So the antiderivative of x to the 4th is 1/5 x to the 5th. Evaluated from 0 to 4. 4 to the 5th power. 16 times 16 is 256 times 4. So that's going to be 1,016. Let's just do it in the calculator to make sure. 1,024. So it's got out of my draw. 1/5 times 1,024 minus 1/5 times 0. That equals 1,024 over 5. And that's the volume of that solid. Cross sections perpendicular to the x-axis. Square cross sections from the origin at 0 to the line x equals 4. Let's add a page here and let's do one with respect to y. Let's use the same function. Thought I could move it in there. There we go. Perpendicular to the y-axis now. In this case, we can do find the volume of solid. With cross sections perpendicular to the y-axis. Whose base is bound by the curve y equals x squared. Y-axis. And the line, we'll go ahead and do y equals 4 this time. If we look at that, here's the curve y equals x squared. This time we're looking for cross sections perpendicular to the y-axis. And the line y equals 4 is our boundary. Now, the other day we talked about integrating with respect to y. And we talked about how it's easier if we can solve our equations for y and integrate orient it where it's on a horizontal axis like we usually do. So I'm going to switch the x and y axis here. And I'm going to flip this across the line y equal x. And you will see that now this is the curve. If this is y and this is x, this is now the line x equals 4. Or sorry, y equals 4. And if we solve this equation for x, we get x equals the square root of y. And so we need to figure out what is x when y equals 4. Well, if we plug in 4 for y, we see that x equals the square root of 4, which is 2. Oh, we really didn't even need that. Sorry, we can just integrate this. We take one rectangle out of there, and we know that that is the base of a solid with a square cross section. So if this is the base, again, not necessarily scale. The width is always this time dy, change in y. The height here is the square root of y. And that makes, since it's a square cross section, this one's the square root of y. And so the volume of one of those cross sections is the square root of y, it's a dy by the way, times the square root of y times dy, which equals y dy. So we're going to integrate to find the sum of all of those volumes. We integrate that 1 from y equals 0 to y equals 4. This is going to be y dy. We know the antiderivative of y is 1/2 y squared. Evaluate that from 0 to 4. We get 1/2 times 4 squared minus 1/2 times 0 squared, which is 1/2 times 16, or 8 units cubed, because we're doing our volume. We're in cubic units cubed. And that's how we do simple ones with respect to y. Next, we'll do some with rectangles.